Okay, so this is going to be a tutorial for Unreal Engine Gore. So what you're going to need is Ballistics VFX and Blood Val FX pack. You don't need these, you can use your own, but I'm going to be using this for the blood splash effects and this for the blood pool decal. So let me get rid of this and this. Okay, so what you're going to need is okay, so we're going to use a third person character. It's pure from base, we've just got rid of the character. So what we're going to do is duplicate, and we're going to get rid of the camera. We're going to put in the mannequin. Let's put the SK mannequin in and give him third person and MVP. So now we can call him AI man. So from here, what we need to do is we need to create a function, and this function will contain damage, hit bones, and the cause. So let's get rid of this because the AI doesn't need to move. So let's call it any damage, and this function will be called in our line trace where we actually fire. So we need 3 inputs. First input is damage, second input is hit bone name. That's going to be of type name, and we need damage causer, and that's going to be of type actor object reference. So promote each of these to a variable. It's going to be applied damage, hit bone name, and damage causer. Okay, so from here we need to create another function. This function is basically just going to change a few things with the mannequin, because right now if we have something like spine 02 dismembered, you see it causes deformation because of the weighting. Same for the head and a few other limbs. But what we need to do is basically tell it, if you do hit these, just point towards spine 01, because that's the one that has correct weighting. But you could skip this step if you fix this yourself. But for now, let's just create a new function called rename bone name. In this function, we need to get hit bone name and switch on name. Now we need to give it a list of outputs, and these pin names will be pelvis, spine 02, spine 03. You could go check these right now and see for yourself the issues they have. We need neck 01 and head. Okay, from here, if it does return true on any one of these, we need it to target spine _01. So from here, let's call rename bone name. Okay, so now once it's gotten past this function, what we need to do is basically have a way of actually applying damage to each limb, because each limb is going to be independent with its own set of values, for example health and durability. So let's call this apply damage to bone. Okay, so from here, what we need to do is create a new variable called breakable bone / durability, and this is going to be of type name, and it's going to be of type map, and it's going to have an integer and a name. So if we compile, now you can see we can add elements. So we need to go give it some inputs. Spine 01 of type of 20. We need to do upper arm R. Let me just keep making these. Okay, so now we need 15, 15, 10 and 10. You can obviously set your own values, but I find these values work best. 15 and 15, 10 and 10, 5 and 5. So now let's call this, and we actually need to find through this index the bone we have hit. So then from here, let's check if it's actually true, and if it does return something, let's get our applied damage, subtract it from the list, make sure this is in the top input A, this is in input B. So if you do the other way around, we're gonna get negative values, and that's not what we want. So now we need to get our list again and actually add. So we're going to input this back into here so it updates its values, and let's get hit bone name for this, and if it's true, add it to the list. Okay, so now we actually need to have a way of checking if it's reached this limit, because if it's not reached this limit, we don't want to get past this function, because after this function we're going to actually be dismembering the bones and breaking constraints. So we don't want that to happen just from hitting the limb once, because if it has gone past this limit, then we should be able to break constraints. So find hit bone name, and if the value is less than or equal to my bad, 0, we need to get return. This way we actually get this output outside the function, and let's call this reach durability limit. Okay, yeah, that's it for this function. So now if we go back, we can call this function and check let's refresh this, and yeah, okay. So now what we need to do is check if it has reached this durability limit, because if it has, now we can proceed on to dismemberment. So create a new function, call it dismemberment. So in this one, we need to get our mesh, break constraint. So now what we need to do is get impulse. So we want it to push the limb away once it's actually been broken, and hit location, we need to know where it's been hit from, so that way we can impulse from the angle, and we need to actually know what bone to break. So first let's get impulse. So let's create a macro, because if we make a macro we can quickly have because we're going to be doing this quite a few times, we're going to need a way of quickly accessing a small little function. Instead of making a function, we can just create a macro. So let's call this calculate impulse, get player camera manager, get actor rotation, get its forward vector, multiply that by float, and we're going to get a random integer in range. This way it gives a bit more of a procedural feel. So 80,000 to 120,000, and then vector plus vector, multiply this by float, and get actor up vector. So now what we need to do is get random float in range. So from 5,000 all the way up to 8,000. So now we just need our output. That will be the return value. So now we can plug calculate impulse into impulse, and now we just need hit location. So for this we can make a new macro called get socket location, and what we just need is mesh get socket location, and the socket name will just be the hit bone name, and plug this into return and plug that in there. So all we just need now is the bone name we have hit. So now we can get onto the visual side. So let's get our socket transform of the bone we have hit, and let's split this because we just need location and rotation. So now let's spawn emitter attached. This I'm going to use the pack, the FX blood valves pack. I'm going to use arterial loop. Let's plug this into location, rotation into rotation. Attached component is going to be mesh. Attached point will be hit bone name. Make sure it's keyboard position. Okay, so from here I'm going to multiply the scale up by 2. You don't need to do that. So let's copy this, paste this. Now we're basically going to layer particles, blood flow, and this will basically follow along with the bone. So let's get our location again, rotation. Okay, I'm going to leave the scale at 1. Attached point name, it's going to be hit bone name. Attached component will just be mesh. Make sure keyboard position is still at keyboard position. And lastly, I'm going to do another one, and this is going to be the initial blood effect of this, like a blood spurt when the limb is dismembered. So blood spurt O2. Okay. Same thing here. Same thing here. Okay. So now we need to check if we're going to have a check if our spine has been broken. because we're going to be referencing this later. We're going to have a special function that happens if the torso has been torn off. We want a different state of movement. So let's check if it's equal to spine 01. And if it is, let's promote this to a variable. Call it has spine broken. Okay, from here, going to get hip bone in, and we're going to create a new variable, and that's called broken bones, and it will be of type name and array. So it's going to be a list. So we can leave this empty because it's going to be updated automatically. So we're going to do add, and it's going to be updated by the hip bone name. So from here, now we're going to have a line trace casting downwards, and this line trace is going to basically spawn in the decals for blood pools. So what we need is mesh get world location. From here we need vector plus vector, and from here we need a vector plus float multiplied by float, and it's going to be -1 on the z-axis. Minus is on the z-axis is down, positive is up, so -1, and it's going to be 1,000. Okay, so now let's get line trace by channel, so that will be the start. No, sorry, that will be the end, and the start is just get world location. From here, let's break hit because we want to access what is hit. From here, what we want is spawn decal at location, and it will be type of blood splatter. Location is just location, and for the rotation we want the normal of the surface. I'm going to use the preset values 63, -128 and -128, and lifespan will be 60 seconds. So from here, that's it for dismemberment. So we need to call this if reach durability limit is true. So now what we need to do is create another function called change movement type, because we're going to have normal and crawling or clawing states. So what we need to do is go here into blueprints, enumeration, and enumeration just holds states, and we can call this movement states. So 2 states, normal and clawing. And the way we can access this is by creating a new variable. This is going to be called movement zombie, and let's just type state, and you can see what's here. Make sure it's not of type array, make sure it's single variable. So from here we can get and check if it's equal to normal. By default it is. So from here, if it's true, let's set movement to clawing. Okay, from here that's it. So now we need to call change movement type. Okay, so now what we need to do is actually apply physics. So apply physics. So from here, let's get hit bone name, switch on name, and we need to input. So this is going to contain all the types of bones that we can actually have physics applied to. Okay, so let's have paste. So these, so foot L, foot R, calf R, calf L, thigh L, thigh R, spine O1. From here we need to simulate physics, set simulate physics. Have that in here and make sure it's true. From here we need to add impulse at location, and like I said before, we can use the macros we've made, calculate impulse and get socket location. Hit bone name is just hit bone name. Bone name is hit bone name, yep. And lastly, we want to disable capsule component and make sure there's no collision. So now that's it for this any damage function. Now we need to go to event graph and call tick. So on tick, what we need is a check. So let's check if we are in the clawing state, is equal to clawing. If it is, let's get a sequence. So we're going to be doing a sequence of things. So do once, delay. So we want to be able to open the gate just once. So after 3 seconds, it's going to open this gate. Make sure it's on open and it can enter. So after this, what we need to do is create another function, and this is going to be called set capsule location. This is going to get or set world location, and it's just going to get the mesh, get socket location, and it's going to get the head, plug that into new world, new location. So that's it for that. And on exit, just set capsule location. So now we need to actually have the zombie crawl towards us. So what we need to do is create a function, and this will be called add force to bones. So what we're going to do is just calculate the zombie's location and apply force to the limbs, and that force is going to be following to the character's position and offset. So what we need to do is get mesh, add force, and it's going to calculate the force by a macro we should make, and this will be called calculate crawl force. So what we need is capsule component, get world location, find lookout rotation, and the target will be the damage causer. So just get to location, and that's our target. So from here we need to get forward vector, multiply that by a float. So that float will be multiplied again by a float, and we're going to have a select float, and it's going to be based on has the spine broken. So 1 and 1.2 should be the values, and here let's just have our input, because we want to be able to define how much force to use. So we should have 2 forward force and upward force. Upward force, float. So from here, what we need to do, we can copy and paste this, and that shall be this value. Okay, so now let's do vector plus float. Vector plus vector, sorry. And we can split this because we only need the z-axis. From here, plug that into output, and that's it for the macro. So now we can get our forward force is 500 and upward force is 3000. Acceleration change, so this would just add on to any existing force, and hit bone name would just be our bone name would just be head. So we've got that. Now let's make another macro, and this will be called find broken bones. So we need to find the existing broken bones. We need an executable pin, and we need a bone name pin. This will be of type name and of type array. So we need to get a copy, and check if broken bones contains item if it does contain either one of these, so we need an or boolean, and if that is true, then we can put those in the outputs. So if we go back, let's call find broken bones. So now we need to make an array, and this will contain our defined bone names. So we need upper arm R, lower arm R, and hand R. And if it does return true on any of these, we can continue on, but if it returns false, we can add force to mesh, and what we need is our calculate cruel force. So we're going to have it 1000 and 1000. Acceleration change is true, and it will be hand R. Okay, from here what we need to do is copy and paste this again, and on true as well, make another array. This time it will be for our left side, and if it returns false, we should add force again. We should calculate cruel force, and it will just be for hand M. And yeah, give it a mesh target, and that should be it for add force to bones. So now what we just need to do is call this. So lastly, for visuals, we are going to have blood pools spawn as the zombie crawls along, and what we need to do is get mesh, get socket location, and hit bone name. So this should happen every 1 second. So let's get line trace by channel. So the start will just be the bone name socket location, and what we need to do is do vector plus vector times by float, and type 1000 and -1 of the z-axis, so pointing downwards. So that will be our endpoint. Okay, so from here, let's break. Let's access its data. So spawn decal at location. So wherever it hits, we want it to spawn location into location, normal into rotation, and it will convert. And we need blood splatter. Lifespan of 60, and I'm going to use minus 31.5, 64, and 64. We don't want it to be too big. So that's it for now. What we need to do is lastly go into our mesh physics tab, and now we just need to give our bones, make sure you enable mass in kg and type 100. From here, what we need to do is actually apply this any damage function, because right now it has no way of being called. We need to call this any damage function, and let's do that by adding we can, if you already have a weapon system, you can easily add it, but we are just going to quickly create a simple firing system. Line trace by channel, get follow camera, get toward location, and get forward vector. As I start, vector plus vector. Just multiply by float by 10,000 units forward, and that's our end. For duration, break it, let's access. So what we're going to do is go to our project settings, physics, and make sure you make a surface type called flesh. Let's make a physics material called flesh. So this is going to play anytime we hit something that has a flesh surface type. Make sure you select flesh. So now we go here, and now we can firstly hit actor. Let's cast to AI man. If that returns true, let's call any damage, and damage, let's have it at 2. Hit bone name is hit bone name. Damage causer is us, so get a reference to self. From here, let's get surface type, and let's switch. Actually, let's do a select so more cleaner, and then let's just spawn emitter at location, and that will be bullet tip. Plug that in here. Let's just do it here. Bullet hit. Okay. Location is just location, and we don't need to change rotation. Okay, that should be it, and we can test it out now. So let's drag in our AI man. Actually, there's one problem. What we need to do is go over here, make sure you select physics actor, because what we need to do is actually have him as a physics body, and it should ignore pawn and vehicle. Make sure it does block visibility. One thing we need to do is set flash. We forgot to apply physics. Okay, yeah. And yeah, you can see him crawl towards us. Simply, that's how you do it. Yeah. You could obviously play some sounds, play around with it. Yeah, you could see it updates and it spawns in those particles, and it spawns in those decals every 1 second as it crawls towards us. Thanks for watching. That's it for this tutorial.